Alright, welcome back. Section 3, Atomic Structure and Symbolism. This video is going to be a review of the subatomic particles and their properties. So, basic atomic structure. The nucleus has nearly all the mass of the atom, almost none of the volume. It contains the protons and neutrons. Proton, P+, has positive charge and about 1 atomic mass unit of mass. Neutron, neutral charge, 0, about 1 atomic mass unit. The nucleus is surrounded by a cloud of electrons that has nearly all the volume, almost none of the mass of the atom. And of course, electrons have negative charge and a weight of about 1/1800th of an atomic mass unit. Now, really quick, we record these things in atomic mass units because subatomic particles are incredibly small, and it's annoying to talk about them in terms of grams or kilograms. And 1 atomic mass unit is defined as exactly 1/12 the mass of a carbon-12 atom. 6 protons, 6 neutrons, 6 electrons. Thus, 1/12 of that, 1.6605 times 10 to the negative 24th grams. Now, the analogy I like to use, I actually got from Bill Bryson's book, A Short History of Nearly Everything. Good read, I recommend it. When it comes to the atom as a whole is like a football stadium with a housefly sitting on the 50-yard line. The nucleus is the size of the fly. The atom as a whole is the size of the stadium. But the fly has the mass of the stadium, and the stadium has the mass of the fly. Okay? That's what we're talking about when it comes to the atom. That is the degree of difference in the scale for the mass and the size of the atom in the nucleus. Almost all the mass concentrated in a very tiny nucleus, almost all the volume in the cloud of electrons with very little mass. So here is a table, a chart, that has all of the subatomic particles in it. Protons, neutrons, and electrons. The proton has an atomic mass, or mass in atomic mass units, of 1.00727, charge 1+. Neutron is 1.00866, charge is 0, and electron has a mass of 0.00055 and a charge of -1. Now, why are the atomic mass units slightly different from 1? Why aren't a proton and a neutron just 1 atomic mass unit? I mean, after all, the atomic mass unit is defined as 1/12 of a carbon atom. So why are they slightly too high? Doesn't make any sense, right? Well, the thing is, it's because of Einstein's famous equation, E = mc². In order to hold the atom together, takes energy, okay? Because those protons are repelled by one another. So, to hold them together takes energy, and that energy comes from the mass of the protons and the neutrons themselves. So the heavier the atom, the more energy it takes to hold the nucleus together, and the lighter and lighter the protons and neutrons get. So an individual proton by itself and individual neutron are slightly heavier than the protons and neutrons of, say, a uranium atom, where it has, 90 protons all crammed together, and then, 140 neutrons, on top of that. So, let's talk about what the subatomic particles do inside the atom. Protons give an atom its identity. Okay? Protons are the identity of the atom. Every atom of an element always has the same number of protons. So that's what John Dalton got right. Every atom of an element is the same because every atom of an element always has a very specific number of protons. Every atom of hydrogen always has 1 proton. Every atom of uranium always has 92 protons. That's what makes it an atom of uranium or an atom of hydrogen. Neutrons are kind of like appearance. Okay? You can get different numbers of neutrons and still have the same element. Okay? So that's what Dalton got wrong. It's not the case that every atom of an element is exactly the same. they can have different numbers of neutrons. So those are called isotopes. Every element has at least one isotope, but they usually have multiple isotopes. And those isotopes are just the different numbers of neutrons. So because they have different numbers of neutrons, they have different masses, and therefore they're going to have slightly different behaviors just because heavier makes you move slower, but they're still going to have the same chemical behavior. So the number of protons or neutrons of an atom can be changed, but only with great difficulty. And that's nuclear chemistry, or particle physics. And the rules regarding the numbers of neutrons is definitely the realm of particle physics and witchcraft. So we don't care about those too much in chemistry. Definitely not first or second semester chemistry. So, an ordinary atom, you know it's going to have a particular number of protons, a very specific number of protons, because that is the identity of the element. The number of protons is what gives it that identity. And if the atom is neutral, has a neutral charge, it will have the same number of protons as it does electrons. So that's also very easy. So a neutral hydrogen atom has one proton, and thus it would have one electron. A neutral carbon atom will have 6 protons, therefore it would have 6 electrons. But neutrons is a little bit more difficult. It's usually about the same number of protons. Okay? Just the way the math works out. But the heavier the elements get, the more neutrons you'll need to hold the nucleus together. So it's not exact. In fact, it's sort of a swooping, curving thing. So hydrogen only has one proton, so it doesn't need neutrons to hold that together. There's nothing to repel it. So most of the hydrogen in the universe is just the one proton and 0 neutrons. And then very rarely you can find what's known as deuterium, a hydrogen atom that also has a neutron. And then incredibly rarely you can also find tritium, a hydrogen atom with 2 neutrons. Incredibly rare. Meanwhile, you have uranium with 92 protons. Okay? It's really hard to hold those protons together, so it has 146 neutrons, or 141, 142, 143, 144, so on. There are lots of isotopes of uranium. In fact, the heavier the elements get, the more likely you are to get multiple isotopes like that. So finally, we've talked about protons and neutrons, identity and appearance. Electrons give an atom its personality. Electrons, because they're really small, really light, and outside the nucleus, they're always coming and going. Okay? They leave the atom, they come back, and so on. It's really easy for them to move around. And 90% of chemistry is about the movement of electrons. Now, most of the time, atoms or molecules are neutral, with equal numbers of protons and electrons. But you can also get different numbers of electrons, and those are what give us ions. So where isotopes have different numbers of neutrons, ions have different numbers of electrons. If your atom loses electrons, that means it's losing a negative charge. So the ion will have a positive charge. We call that a cation. It has fewer electrons. Well, cats are small, fewer electrons, less negative. Cats are always positive. Cats are always happy. Don't let anyone tell you different. Now, if you gain electrons, you're gaining negative charge. You have a negative ion, and that's an anion. It has more electrons. Annie is always negative. I've never met a person named Anne or Annie who was never unhappy. Annies are always negative. That is a fact. You'll never change my mind. All right. So it's important to remember that ions are very, very different from one another and from the neutral atom. Okay, moving electrons around like that changes the personality, changes the chemical properties of the atom. And that'll do it for talking about the subatomic particles. See you next time.